Hi, welcome to the second erosion PowerPoint slide. In this video, I'm going to click through the slide and kind of explain things and show you what's going on to give you a better understanding as to the development of streams. On the first slide here, we can see a picture in the top right corner of the three stages from youthful to mature to old age. The big difference is the overall gradient, the steepness of this, giving it a straight channel. In the mature, we have a moderate slope, and we have some meanders starting to occur. And in the old age, we have a very gentle slope where the stream is carved down most of the landscapes and it's very flat. Here we can see the notes for the youthful stream. We have the typical V-shaped valley that we see in all rivers and streams. So we want to remember that V-shaped valley for rivers, R-I-V-E-R-S, rivers. So the V is in there to easy to remember. We see very fast moving water because of that steeper gradient. We typically have a straighter channel than we see with the other stream ages. And we see no floodplain. So there's no floodplain to the left or to the right where the water would have eroded the material away. Looking at the velocity of a straight channel here, we can see the speed is fastest in the middle. That's because the edges are where the water is making contact with the sides of the riverbank and slowing down. Here we can see the V-shaped valley in this picture. It's not as defined as before, but we have the very steep sides of the valley moving across the landscape and the water moving down the middle. We can see rapids and waterfalls in youthful streams. Rapids are a resultant of differences in the resistances in the rocks and big boulders not moving and not eroding out of the way. Waterfalls, here we have a development of a waterfall. The waterfall existing because of different resistances amongst the layers. These layers down here are softer and less resistant than the layer on top, and the water eroding away that material, moving it away, leaving the top piece left alone. This video here kind of explains how that works. This question asks about Niagara Falls and the direction of movement. We can see here the falls on the edge, and the interesting part about that is this map is upside down. North is to the bottom, typically north is to the top. So if we were asked the question about how or what direction the falls would be moving, we could see the falls would be moving and eroding towards the top, which would actually be in a southern direction. For a mature age stream, now we can see that there is lateral erosion. That's the stream moving back and forth, eroding away, presenting the floodplain. This also starts the meandering process where the river starts to erode and weather the sides away in different patterns, giving it a wider floodplain and showing the river wander downhill. Here we see that meander happening, a little more pronounced. In the left picture over here, we see the river kind of moving left and right. Over here, we can see it widening the bed around it, the outwash plain around it. This slide here shows how the river flows and how this produces the meanders. The thing you got to remember about this is the water moving downstream is moving at different paces. The inside most part of the bend is going to have the slowest water. The outside part of the bend is going to have the fastest water. We have to remember that water is adhesive. It sticks to itself. So as the water moves downstream, the inside has a shorter path to take, and the outside has a longer path to take. So if they were to be together, the outside has to speed up to stay with the inside. That outside turn, because it's so fast, is going to erode away the rocks and the edge of the riverbank more on the outside because it's so fast. On the inside, where it slows down, the particles are deposited and dropped off, which is producing more land, and the outside part is eating away at it. In this cross section down here in the bottom right corner, we can see the outside part of the riverbank being eaten away and getting deeper, whereas the inside part of the riverbank is more shallow. So we have erosion on the outside, where it's fast, deposition on the inside. So if we were to walk into the river from the riverbank on the left side here at A, this would be an easy way to go in. It would be nice and gentle. But if you were to come from the outside here at B, on the outside part of the turn, it'd be super steep. You would fall into the river here and get swept away. So now we get to see that on a larger picture. We can see the stream moving, making a couple turns. Each of the outsides are moving faster, and there's erosion. The inside is where our deposition is happening. The outside here is called a cut bank. The inside is the point bar. So you have erosion on the outside, deposition on the inside. Erosion on the outside, deposition on the inside. We can see that they're the same but flipped. Again, it flips back the other way. Erosion on the outside, deposition on the inside. Erosion on the outside, deposition on the inside. There's a screencast of another teacher teaching this unit, so take a look at that in the videos. A couple videos here to watch as well. Picture here of a cut bank and a point bar. You can see the river turning and meandering, and the outside is where the river is moving faster and eroding the material away. The inside is where it's moving slower and it's depositing, and all of this material here was deposited by the river. So you can imagine the river actually had turned right here. This was all underwater at one point, but now it's meandered all the way over here because of that erosion on the outside and deposition on the inside. Classic question. We have A and B on the outside, C and D. So if the question was which one of the three pictures here, 1, 2, or 3, would match the stream channel at A and B, we would have to go with choice 3. The outside part of the stream is where it's fast and eroding, so it's deeper here. The inside's where it's shallow and depositing, so it's shallow here. C and D, we see something like we have in the top portion here, where the inside is where it's depositing and it's slow. It's here. And the outside is where it's being eroded away and it's deep. Okay, so we have the same kind of question, just a different angle on it. A to A prime. We're looking at erosion on the outside, deposition on the inside. So that is going to be choice 4. Here we have X and Y. Question is asking about X and Y. And we can see that there is no turn at X to Y. So because there's no bend or there's no turn here, this is going to actually be a pretty straight channel where there's no deep part and no shallow part. So we see that here, X to Y for choice 2. If we were looking more towards B and C and substituting in values for X and Y, we would see the outside part of the turn at X or B being deep and the inside being Y, more shallow. All right, here we have A, B, and C. Again, we want to establish where the outside part of the turn is. That's at C. That's where the erosion is going to happen. So it's eating away here. So we're looking for C where it's deep. And then A is the deposition. So it's going to be shallow there. The old age streams, we can see more meandering happening, and we have these oxbows. We'll talk about those oxbows in just a minute. But we have a very large floodplain as the stream meanders switchbacks and produces a lot of these oxbows. Here we have that again, a very meandering stream. We have some oxbows here, maybe one producing here. The oxbow is basically a meander that has come so close that it gets cut off. And when that happens, the outside part of the turn meets another outside part. They're eroding away and eventually get close enough that they snap and cut this off, and the Oxbow Lake is left behind, and the stream continues in a straight fashion. A couple videos here showing that. You can go and look at those. Here's a picture of that straight channel and the Oxbow that's left behind. You can see that there are a few of them as the river moves down. And here's another section over here that's probably going to produce an oxbow. Watch these two videos. Which sequence shows the proper stream development? Remember, we're always going to look for a very straight channel to begin with. We're going to start with D, very straight channel, and no floodplain here. We can see that A, it's got a very small floodplain. It's pretty straight, so that's going to be the next one. So it's going to go D, A, then it's going to C. Floodplain is larger. We're having some meanders and one oxbow. And then B is going to be our last stage, our old age stage. We have the largest floodplain. 1, 2, 3, 4, 5, maybe 6 oxbows or evidence of oxbows in the area, like here. So again, the order is D, A, C, B. This is an interesting map picture. Take a look. This is the floodplain of the Missouri River. I think it's the Missouri River. Yeah, Missouri River. And right here is a school. And the question is, is that school in danger? If this Missouri River were to overflow, this entire flood bank could be filled with water and possibly sweep the school away. So, interesting. Remember that during transport, we're taking those angled pieces and we're rounding them and making them more smooth. That process is called abrasion. Remember that we're abrading the materials as they move downstream. We're also sorting the materials. We're going from a poorly sorted phase to a well-sorted phase here. That has to do with the deposition. Here are a couple videos showing the sorting of material. As the velocity slows down and the stream comes to a larger body of water, the larger particles are going to get dropped off, and the medium-sized particles get dropped off, and the smaller particles go the furthest out. It's because the velocity slows down and the stream can't carry them anymore, so it goes big, medium, and small. Watch these two videos. There's some good information in there. Deltas form at the mouth of a river. This is the Mississippi River coming out into the Gulf of Mexico, and it's a depositional feature. We can see a lot of buildup of particles at the mouth of the river, bigger, medium, and smaller, the further it goes. Check out these two videos. They're pretty good. Check out this video on a delta here. There's another video on the delta here. This has to do with vertical sorting and how it happens, and it sorts vertically instead of horizontally. Here's a picture of that vertical sorting. So real quick, what he does is he takes a whole bunch of particles, shakes them up, and stops. And as soon as you stop shaking those particles in the water, the biggest particles are going to settle first to the bottom. And then the medium ones come next, and the smallest ones take the longest time to sort down to the bottom or to settle. And that produces what's called vertical sorting. If this happens season after season, we get these layers called graded bedding, where it's vertical sorting on top of vertical sorting. And that's it. Stay tuned for the next one.